आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics, and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
In this episode of the podcast, we are immensely happy to have Dr. Amit Kumar Pal with us. He will now be introducing himself and will also share his academic journey.
Myself, Dr. Amit Kumar Pal. I am working as an associate professor in the Department of Chemical Sciences at the Bose Institute. I did my PhD in 2013 from Indian Association for the Cultivation of Science, and then I moved to Texas Tech University and did my postdoc for 3.5 years since 2013 till middle of 2016. And then I came back to India and joined NIT Meghalaya in Shillong, and I worked there for 8 long years, and then 7 months before I joined Bose Institute as an associate professor. And in my group we work on various kind of computational dynamics and on the molecular systems, for example, classical molecular dynamics, semi-classical dynamics, excited state dynamics, QMMM kind of dynamics. And I'm also currently acting as an editorial board member of one of the old journals called International Journal of Chemical Kinetics. And in 2022-23, I was awarded as the best researcher of NIT Meghalaya at that year. And that's all.
Dr. Pal will now share his research work in a nutshell.
In our group, we do various kinds of dynamics at the molecular level. And what is a dynamics? Dynamics is how an object is moving as a function of time and the forces that causes this movement. So that we deal at the molecular or atomistic level in our research group.
Dr. Amit Kumar Pal will now elaborately explain his area of research.
As I said that we work on various kinds of dynamics, and there are many kinds of dynamics. In 2013, Nobel Prize also given to one of the computational methods called multiscale modeling. So in our group, we actually deal with all kind of dynamics. It depends on which kind of problem you are handling, and then you can choose the model of dynamics that you want to impose for a particular system. To be very specific, in one of our current interest is a molecular system where the molecules are bound very weakly to each other. So there are two molecules which are bound very weakly to each other. These are called van der Waals interactions, because if you just excite this molecule, this bond will break. So we are currently interested looking at the association-dissociation pattern of this weakly bound molecules. And so, for example, if I took an benzene dimer and two benzene molecules, they form a complex. Okay, and if I excite this molecule vibrationally, so there are 3n minus 6 number of vibrational modes, where n is the number of atom. So this many vibrational modes get excited randomly, experimentally. Now, then the energy for every mode should be redistributed within the molecule. So if I have X energy in one mode and Y energy to other mode, they are subject to redistribution among the all modes. That is a very common phenomenon for every molecules, and that is called intramolecular vibrational energy redistribution, in short IVR. So we are dealing with IVR problem. So if we found out that if the molecules are weakly coupled, then the vibrational modes for this coupling is very weak, and there is a IVR bottleneck between the modes with high frequency and the modes with low frequency energy not redistributing, which should be there for every molecule. And we are particularly focusing on this in our research group. And we have a series of molecules that we studied, and we find out that you have to have a very not only a very good coupling, as well as the frequency should be within a limit between the intramolecular and intermolecular. So that is one of the particular project that we are currently working on. Now, this kind of projects is very relevant in case of combustion chemistry reactions. For example, in fuel burning, in the combustion chemistry, when the fuel gets burned, then everybody of us see the soot particle that is coming out. Now, the soot particle are nothing but polyaromatic hydrocarbon molecules, they bind together. Now, at the combustion temperature, how could they bind when the binding energy is not too much, right? So that is particular applications of this project that we are currently working on. And in India, there are other few groups which are also dealing with it in experimental ways. And internationally also, there are groups, pioneer groups in UC Berkeley and many other universities who are also dealing with this problem.
Dr. Amit Kumar Pal will now focus on the way forward.
Actually, people are working on this in the combustion chemistry field. Particularly, people wants to know why the soot particles are forming. The mechanism of formation of soot particle is still unknown very precisely. And if we can figure out the particular reasons of how the soot particle is forming, it is of course an incomplete burn of the fossil fuel. But if this mechanism gets fully understood, probably we can control the pollution in future. So therefore, there are many groups, experimental and theoretical groups like us. They are currently working in this, and the example that I gave of benzene dimer is a very model example, but actual systems are quite big. People are also trying to handle the big systems in computationally, which is a challenge, of course. But we are also currently focusing on a bigger polyaromatic hydrocarbon systems and properly trying to understand that how they bind, and if they bind, how long can they sustain. Okay, so it has some direction to work on the futures, particularly to fully understand the mechanism of the formation. I think if we can understand the mechanism, probably we can minimize the formation of soot.
Dr. Pal will be sharing the information regarding the collaboration in the country and also speaks on India's position in the international scenario.
In India, people are working in this, very senior professors from IISc Bangalore and very young faculty members who joined very recently at IIT Kharagpur. So we are doing in collaboration. We are working in collaboration, and we are also trying to understand the mechanism. There are experimental groups who wants to know the details at the molecular level, that we are helping them. And yes, in India also, we are not far away from the world scenario. We are also trying. There are many groups who are working on this.
We are extremely thankful to Dr. Amit Kumar Pal for sharing a piece of his journey with us. Thank you so much.